Welcome to lesson 48. So we're going to talk about the Model Utility F-test. This is really similar to a couple of weeks ago when we were talking about the single factor ANOVA test. It's still going to be the F distribution that we use. It's still going to be a, hey, is at least one of these variables useful? That kind of idea. But the format might be a little bit different. So we're going to go over hypotheses. We're going to go over the conditions that are assumed, as well as F statistic, and review the F distribution. So the Model Utility F-test. So the example that we're going to use throughout week 9 is going to be the Mario Kart example. So we have a random sample of 141 eBay sales specifically for Mario Kart. And we have the starting price of the bid. So bidding, it's when you bid, it's an auction, people can up the price, that kind of idea. The number of Wii wheels, because this was sold by the Wii, or Nintendo Wii, and the condition, so if it's new or if it's used. We had an R squared of about 75.8% and an adjusted R squared of 75.2%. So our equation here, it is important also to include, I would say, y hat is the predicted selling price. It is extremely important, I really can't stress enough, to label. If you use y hat, you need to tell me what y hat is. If you use x1, great, but you have to tell me what x1 is. So x1 here is the starting price of the bid in US dollars. x2 is the number of wheels. So the number of wheels, this is going to be 0, 1, 2, 3, or 4. And then x3 is condition, new or used. So x3, it's going to be 0 if new, 1 if used. So it's the values for x3, it's going to be 0 or 1, depending on if it's new or used. Suppose we want to formally test whether, hey, is at least one of these variables useful in predicting the selling price? So this is where it really should sound familiar to the single factor ANOVA week that we had. So how do we formally test? We have a Model Utility F-test or overall F-test. This says, is at least one of these explanatory variables useful? If you conclude that at least one is useful, then you move forward and decide, well, which ones are useful? So for our Model Utility F-test, this is when you want to determine, is at least one of these explanatory variables useful in predicting what's going on with the response variable. So how useful is our model? So here for our conditions, we're always going to, and it should look really familiar by now, we want a representative sample. So we want the sample to represent the population. The easiest way, the most straightforward way, is going to be if we have a random sample. But the big thing is that we can assume that this sample represents the population. We are going to need our residuals to indicate the 4 conditions of inference are met. So it's going to be slightly different from here, but we're still going to look at linearity. Was a line appropriate to fit? Are the observations reasonably independent from one another? Can we assume normality? And can we assume constant variance? It's going to be the same as those assumptions from last week. We'll specifically look at a plot called residuals versus fitted. So we'll look at what the line predicted those values would be versus what they, how much they missed by. And then we do need our sample. We need our sample to be bigger than, the number of explanatory variables plus 1. So if you have 9 explanatory variables, you need to have a sample of at least 11. It's really honestly kind of painful if you have a sample of 10 and you're trying to fit 9 explanatory variables. It's too many explanatory variables for too small of a sample. So our null and alternative hypotheses. So this is going to be the part that looks really, really similar to the single factor ANOVA. By default, we assume that none of the explanatory variables are useful in explaining what's going on with the response. The alternative says, hey, at least one of them at least one of the explanatory variables is useful in explaining the response. It doesn't say which or how many, it just says at least one is useful. So yes, once again, the explanatory says at least one. It doesn't have to be that all of them are, at least one of them is useful. So our F statistic is going to be this equation here. Most of the time, this is not something we calculate by hand. R is more than happy enough to calculate this for us, but absolutely. So telling us what these things are. So we have our R squared. So this is not the adjusted. Be careful. K is the number of parameters or explanatory variables you've added. And over 1 minus R squared divided by our sample size minus the number of parameters minus 1. So keep in mind the denominators on both the top and the bottom. This is my numerator's degrees of freedom. And this here on the bottom, that's my denominator degrees of freedom. Because it is an F statistic, the F distribution is this really, really right skewed distribution. It's always going to be an upper-tailed test. So we're always going to look at a higher probability here. High tail. So F distribution, reminding you, it's positively skewed or right skewed. So the tail is over here. And it goes from 0 to infinity. We define it by numerator degrees of freedom. So nu 1, this is a Greek letter nu, and denominator degrees of freedom. So we'll denote it as an F statistic with numerator degrees of freedom nu 1 and denominator degrees of freedom nu 2. So as your degrees of freedom get higher and higher, it's going to look more and more symmetric. And it is a ratio of chi-square distributions, which is handy, especially if you go into like a master's in stats, but we're not going to really necessarily test you explicitly on that. So for the F-test, the p-value, it's going to be that area to the right. It's always going to be that upper-tailed probability here. So this is just an example of some R code. We will include this at the end. So if you look at the slides towards the end of this week's notes, this will be included there as well. So our Model Utility F-test. So we're looking once again at our Mario Kart example. We're looking at using the selling price, the number of Wii wheels included, and condition either new or used to help explain the selling price of the unit. So we took 141 eBay auctions. We want to test whether at least one of these variables, so starting price, number of wheels, or condition, are useful in explaining the selling price. So our steps, they're going to be identical. We're going to state our question of interest. We're going to talk about our parameters of interest, our significance level, and so on, as any hypothesis test. So our question of interest. In this one, it's not going to be in notation so much. It would be a lot more complicated to do so. It's possible, but complicated. Is at least one of the variables, starting bid, number of wheels, or condition, useful in predicting the mean selling price. So is at least one of them useful. So here, my parameters of interest, I'm going to have, it's going to go a little gnarly there. Beta 1, beta 2, beta 3. Remember that beta 0, that's the y-intercept. We don't test that one. We only want to have a beta for each of these here. So that is what we're going to be interested in here. We're interested in is the starting price useful? Is the number of wheels useful? Is the condition useful? Note that only the condition is really a categorical variable. How many betas are added for a categorical variable gets more complicated. And we do have an explicit example that we go through for indicator variables after this one. So here then, my significance level, that's going to be 0.05. That's our default, but also it's included here. So there you go. So basically I want to know, are at least one of these betas not equal to 0? That would be useful to know. So here, I want to go ahead and test. I'm going to say beta, what did I have them called? Starting price is equal to my beta of wheels equal to beta of condition is equal to 0. So by default, I'm going to assume absolutely none of these three variables are useful in predicting selling price. And then I'm going to say at least one beta I is not equal to 0. And for me, I like to say beta I can be starting price, STP, wheels, or condition. I would probably write more explicitly what each of those stand for. Absolutely, that's useful. So then I go into conditions. Is the sample random and represent the population? So we took a random sample of 141 auctions. So over whatever period of time or whatever that we took these auctions from, yes, I would say because it's a random sample, it is representative. Then we want to say, do the residuals indicate the 4 conditions of inference are met? So as long as the 141 randomly selected auctions are not related to one another, so you might want to indicate that it is important that it's not the same individual selling or whatnot, independence would be met. But looking here, it looks like fairly, I mean, it's harder to tell out here, fairly even spread across. So I would say that the constant variance is met. Normality, I would want to look at this normal QQ plot. Looks here like, I mean, there's a little deviation from that line, but these points, they fit this line pretty well, which would mean yes, the normality of some condition is relatively well met. For linearity, I want to look here again. So the residuals versus fitted plot. Here is where I look, is there a big old curved pattern? Is there something that tells me that fitting a line was inappropriate? And I don't see anything. I mean, there's an oddball point here, but I mean, it's pretty much like, there are definitely fewer observations out at the end. But I would say yes, the residuals indicate they're roughly well met. I would say there's roughly even scatter. Obviously, there's some sort of lines here, and that might indicate that people set like at certain prices, that kind of thing. Or the fact that they could only have 0, 1, 2, 3, or 4 wheels, that kind of thing. So these streaks don't necessarily mean something so much as I don't see some big curve or some big fanning out or funneling in. So since I don't see that, I think things are good. So looking at this example, if I want to put my test statistic here, it's going to be here. Here's my F statistic. And not only that, it gives me all the other information. I have an F statistic of, sorry, just like my mic's in my way. I have an F statistic equal to 142.8 on numerator degrees of freedom. It's always the first one we list, 3, and denominator degrees of freedom, so 3 and 137, 137. And I have a p-value that's less than 2.2 times 10 to the negative 16, which is really, really tiny. So here, I'm going to say my p-value, I'm going to say it's less than a small number, so 0.0001, because that's true. That is fine. Either we usually say that our p-value is below 0.001 or 0.0001. So 1 in 1,000 or 1 in 10,000, they're both pretty small. I'm going to fill out the other. So it's an F statistic of 142.8 on 3 and 137 degrees of freedom. We used a 0.05 significance level. So now I'm going to decide if I have a p-value that's really tiny, much smaller than our significance level, I'm going to reject the null hypothesis. So remember, the null hypothesis said, hey, none of those explanatory variables, starting price, number of wheels, or the used or new condition, are useful. So if I go ahead and I reject that, I'm saying, hey, at least one of those is useful. So there is very strong evidence, or convincing, that's fine as well. There's very strong evidence at least one of the variables is a good predictor of what is our response. It's selling price. And you could be more specific, so of Mario Kart on eBay, that kind of thing. There you go. You could probably even be more specific and say year. I don't know the specific year this was taken from. So here, if we go ahead, we want to test whether any of them are useful. This is just reiterating our results here. So we reject the null hypothesis at the 0.05 significance level. This is just notation-wise. Remember that the degree of freedom we put first is going to be the numerator degree of freedom. So 3, 137. So all of this is found at this last line here. With a p-value that's less than 0.001 or 0.0001. Ours default, like when p-values are really tiny, for some reason it cuts off at 2.2 times 10 to the negative 16. Yes, that's tiny, but it's totally okay if you just say, hey, it's less than 1 in 1,000 or it's less than 1 in 10,000. That's small enough for us. So from this F-test, there's convincing or very strong evidence, at least one of the variables, list them, is a significant predictor of total sale price for auction sales of the Nintendo game Mario Kart on eBay. So next up, lesson 49. We'll see you there.